Look, my hair is standing up.
It must be because of your sweater. You created static electricity.
How did it do that?
Well, when you took off your sweater, it rubbed against your hair, and it caused electrons to transfer.
So the electrons charged my hair.
Well, actually, it charged your hair and your sweater. The static electricity created a magnetic effect, so your hair is like standing up.
No way! I don't believe it.
I can prove it to you.
Why does your hair stand up on end when you take off a sweater? How can an object be charged positively or negatively? How do two objects act when they have the same or opposite charge? Let's find out.
Hey everybody! Welcome back to Moon Kong Simple Science. Now sometimes in the winter, when you take your sweater off, you might notice that the hairs on your head start to stand up. Now this happens because of static electricity. Static electricity can do some pretty fun things, and we'll look at that in some experiments today. So let's get going with your first experiment. Now, in this experiment, let's use static electricity to try and make this balloon stick onto this scarf. All right, what do you think will happen? Here we go. Okay, so what you noticed was the balloon wouldn't stick onto the scarf. Now this happens because neither object is charged with static electricity right now. Since they aren't charged with static electricity, they are what's known as neutral. Now two neutral objects don't attract each other, so as a result, the balloon doesn't stick onto the scarf. Okay, now in the second experiment, let's try and make some static electricity so that the balloon and the scarf will stick together. Now we can do that by rubbing the balloon on the scarf. So let's do that about 20 times right now. Okay, so let's give it a try. Okay, so what you notice is the balloon is sticking onto the scarf. Now this time, both the balloon and the scarf have static electricity. As we rub the balloon over the scarf, one loses electrons and one gains electrons. In this case, electrons move from the scarf into the balloon. So as a result, the scarf is positively charged because it loses electrons, and the balloon is negatively charged because it gains electrons. As a result, they are oppositely charged. Now when two oppositely charged objects come together, they attract each other and stick on. That's why the balloon sticks onto the scarf. Okay, now in the third experiment, let's try the same thing we did in experiment 2, except let's rub two balloons on the scarf and then see how the two balloons act toward each other. Let's do that now. Okay, so let's try and make these come toward each other. Okay, let's try it again here. Whoa, look at that. So, what do you notice? Well, you see that every time we try to put them together, the two balloons move away from each other. The balloons repel each other. Now, as you know from experiment 2, rubbing a balloon on the scarf causes it to gain electrons and become negatively charged. So both of these balloons are charged with negative static electricity. When we try to put two objects with the same charge together, they repel each other. So that's why the two balloons pushed away from each other when we tried to put them together. Okay, let's review what you've learned today. Now when two objects rub together, one loses electrons and one gains electrons. Now, static electricity can give an object a positive charge or a negative charge. Two objects with the same charge repel, while two objects with opposite charges attract. Well, that's all the time we have for today. So the next time you're taking your sweater off, take a look in the mirror and see if static electricity is making your hair stand up. I'll see you next time. Goodbye.